friends, thank you for joining me. In today's presentation, we continue with bearing and distance. In today's lesson, we're looking at keys in finding bearing and distance. Keys in finding bearing and distance. There are certain keys that you need as far as finding bearing and distance is concerned. Number one, the first key is after you finish drawing, if the resulting triangle, after you finish drawing the bearing, if the resulting triangle, number one, that's key number one, the resulting, if the resulting triangle is a right angled triangle, then to find bearing, we use the knowledge of trigonometric. To find bearing, we use trigonometric knowledge. Trigonometric means that is, we use SOHCAHTOA knowledge. We use SOHCAHTOA. That's sine opposite of hypotenuse, cos adjacent of hypotenuse, tan opposite of adjacent. We use this knowledge to find bearing and basic properties of angle and basic properties of angles. This is key number one. If the resulting triangle is a right angle means when you have 90 degree, after you finish drawing the bearing and you have 90 degree. To find bearing, we use what? We use trigonometric, that is SOHCAHTOA and basic properties of angles. Under this number one, let me put Roman numerals 2. Again, if the resulting triangle is a right angle triangle, to find bearing, we use trigonometric, that is SOHCAHTOA and basic properties of angles. Then to find distance, that's why I put it Roman numerals. To find distance, if the resulting triangle now is a right angle, the keyword here is right angle triangle. To find distance, we use we use Pythagoras rule. We use Pythagoras rule. To find distance. We use Pythagoras rule. Very important. Okay, if the resulting triangle is a right angle triangle, number one, to find bearing, we use the knowledge of trigonometry, that's SOHCAHTOA and basic properties of angles. Then to find distance now, we use what? We use Pythagoras rule. Very important. This is key number one. Let's move to key number two. I will label it as number two. If the resulting triangle, that's after drawing the resulting triangle, if the resulting triangle is not a right angle triangle, if it is not a right angle triangle, it could be up to maybe 105, 120, like that. If the resulting triangle is not a right angle triangle, if it is not a right angle triangle, number one, under number two, now Roman numerals 1, to find bearing, we use cosine rule or sine rule. We use what? Cosine rule or sine rule, as the case may be. So, if the resulting triangle is not a right angle triangle. If it is not a right angle triangle, meaning it could be obtuse angle or reflex angle as the case may be. To find bearing, we use cosine rule or sine rule. Very important. Okay, let's clean this number one since we're through with this. Roman numerals 2 now. To find distance. Okay, to find bearing, we can either use cosine rule. Okay, let me say to find bearing, we use sine rule. Sorry, to find bearing, we use, let me clean this, we use sine rule. We use sine rule and basic properties, basic properties of angles. Let me repeat it again. If the resulting triangle is not a right angle triangle, to find bearing, we use sine rule and basic properties of angles. Roman numerals 2. If the resulting triangle is not a right angle triangle, to find distance, we use cosine rule. Very important. These are the key things that you need to know as far as bearing is concerned. Let me take number 3. Key number 3 now. The word from in bearing is key. Like let's say the bearing of A from B. It means when you hear the word from in bearing is key. It's very important, this word from. The bearing of A from B means the bearing of A will be constructed at B. The starting point will be B. That's what it means. The bearing of A from B. It means the starting point is at B. Very important in bearing as far as this word from, as far as bearing is concerned. Very important. Then you are drawing, you have to be realistic in your length. You can check my previous video. I've done justice to that as far as concept of bearing is concerned. We're looking at the keys to bearing. When you draw your bearing, how when you finish the drawing, how do you find the bearing? How do you find the distance? Because these are the key questions the normal asks. They may decide to say find the distance between these 2 points, then find the bearing of this point from this point. These are the likely questions the normal asks as far as bearing and distance is concerned. So these are the keys that you need in finding bearing and distance. Let me repeat it again verbally. Number 1, if the resulting triangle is a right angle triangle, to find bearing, we use the knowledge of trigonometry, that is SOHCAHTOA, and basic properties of angles. That's to find bearing. To find distance, if the resulting triangle is a right angle triangle, the resulting triangle means after you finish the drawing, then you have 90 degree, that's right angle triangle. To find distance, we use Pythagoras rule. Very important, use Pythagoras rule. That is key number 1. Key number 2, if the resulting triangle is not a right angle triangle, to find bearing, we use sine rule or basic properties of angles. Roman numerals 2 under that. To find distance now, when the resulting triangle is not a right angle triangle, we use what we call cosine rule. Very important. Thank you for watching. Please do share this to your learned colleagues. Don't forget to subscribe to TJ's Maths and Further Maths Adventures. You can follow me on TikTok, Instagram, and Facebook. You can check my previous video to look at the concept of bearings and distance. These just keys to bearing and distance. Thank you for watching. See you in my next video.